Okay, welcome to part 2 of our video that we were doing on writing equations for lines. So we're going to go ahead and jump into a couple more here. This one tells you that the ends of the diameter, so we're looking at this circle and the ends of the diameter. Again, remember the diameter goes through the center. They are at a negative 17, negative 9. And at a negative 19, negative 9. And we want to find the equation. So I'm going to need two things. I'm going to need the radius, okay, which the radius in this case is going to be half of the diameter. So I can find the distance, use the distance formula, and find the length of the diameter. And then I also need the center of the circle, which is going to be halfway between the two, or the midpoint of the two. So I've got two things to find here, distance, the length of that diameter, and the midpoint. So let's go ahead and get started. So we're going to run our distance formula. So negative 17 minus a negative 19 squared, and a negative 9 minus a negative 9 squared. So let's simplify that. Double negatives, that's a plus. So negative 17 plus 19 would be 2 squared. And same thing here, so that's 0 squared. So my diameter, or my distance, which is my diameter also, is going to be just 2. Okay, now that is my diameter, so my radius is half of that, so my radius is 1. Okay, now that's given us this. I know this is 1. Now I need to go find my center. My center is my midpoint. Remember, to find midpoint, it's like the average of those 2 points, what's in the middle. So I'm going to add the 2 and divide by 2. So I have a negative 36 over 2 and a negative 18 over 2, which makes it a negative 18, negative 9. And that should kind of make sense that if I'm at a negative 17 and a negative 19, that I'm at a negative 18. And then again, a negative 9 means that diameter is actually on a horizontal line. So that should make sense. Okay, my equation then is going to be my center. Okay, this is my center. So x plus, because of double negatives, 18 squared plus y plus 9 squared equals radius, which is 1, squared, which is 1. And so there will be my equation given the endpoints of the diameter. So as you see, we found a lot of different equations given a lot of different information. Okay, so I'm going to go ahead, just for spacing and room here, I'm going to delete off my stuff here. If you wrote as big as I did and need a spot, you can probably use some space over by your graph here on this next one, or you can always put it on another sheet of paper, whichever the case may be. Okay, so this one, we're going to be talking about the center, and it is the line tangent to. Now remember what we said tangent to was just that line that comes through and it hits, and it is perpendicular to your radius. Okay, perpendicular to your radius. So let me just do a quick sketch of what we have here. So on this one, I'm not going to do it to scale, but we are at a negative 2, 12. We'll call this 12. Okay, so this is a negative 2, 12. That is the center of my circle. But I know it is going to be tangent, 1, 2, 3, 4, 5, tangent to x equals a negative 5, which is a vertical line over here. Okay? So that means, again, this radius is going to be from here to here. Okay, so my circle is going to sit in here somewhere, like that, and there's the tangent. So if I know this one is over at a negative 2, and this is at a negative 5, I know my radius is 3. everybody okay with that? So sometimes on doing these equations with tangent to, you might need to kind of sketch a picture to see what's going on. But basically, it is the center, from your center to your tangent line. Okay? So my radius is 3. I'm not going to need to do any other work. So my equation is x plus 2 squared plus y minus 12 squared equals radius squared, which we said our radius was 3, so that's 9. Okay? So the next one says the line tangent to the circle at the given point is what we're wanting to find. So we're not finding the equation of the circle, but we're going to find the equation of the line. Okay? So first off, we're centered at the 0, at the center, and my radius is going to be the square root of 17, which is just going to be a little bit over 4. So I'm just going to barely put it over 4. Okay, so kind of sketch in. Okay, not perfect. But then it says that it hits at 1, 4. Okay, which should kind of make sense because this was a little over 4 that hits at 1, 4. So let me draw my line in. So my tangent line is going to come through here. Whoops, not quite straight. But the key is that it's perpendicular. Maybe if I draw that a little better. It's going to be perpendicular to, drawing these lines, and okay. So this is going to hit here at 1, 4, come down through here, but it's going to be perpendicular here. Okay? Mine is not to scale by any means, so it looks kind of rough. But so what we're going to need to know, since it's perpendicular, if I know the slope of this line, then I know the slope of my perpendicular line. Okay? So how are we going to find that? Well, I know this is at 0, 0, and I know this is at 1, 4, so I can just do rise and run. Rise 4, run 1. Okay? So my slope is 4 in this case. Therefore, my slope of my line that is perpendicular would be a negative 1/4. So I know the slope of this line, so the slope of my green line, and I know it goes through the point 1, 4. So now I can either do point slope or y equals mx plus b. Okay, so I'm going to do my point slope. So y minus y equals slope x minus x, and I'm going to distribute. Okay, and then I'm going to move my 4 over. So y equals a negative 1/4 x, and then this would be 4 1/4, so I'm going to write it as 17 over 4. And then that would be my equation of the line tangent. Okay, so again, go back over what we did. I looked at my circle, and because of the fact that my tangent is perpendicular to this line, okay, perpendicular to that line, going through that point 1, 4, that I can just do the slope of my radius, do the perpendicular reciprocal to get the slope of my tangent line, and then use that point and the slope to find my equation. Okay, let's try another one. Now this one, it says the line tangent to the circle. So this time they're going to give me the equation. So it is at 2. So my center would be at 2, negative 1. It's going to have a radius of 5. So 2, negative 1. It has a radius of 5. 1, 2, 3, 4. I did not put a big enough piece of graph paper on here. 1, 2, 3, 4, 5. Did I count that good? There we go. 1, 2, 3, 4, 5. Okay. And so whoa. graph that in. I was just going to recount here. Okay. Again, my circle is by no means perfect. Let's see if make that a little bit rounder here. Sometimes I kind of have to make it not super smooth just to get it. There we go. Okay, and then it says that it hits the point 5,3. So let's get that point on there. 5, 1, 2, 3, right there. So mine did hit there. So again, here's my radius, perpendicular. You've got a line that's coming through here that's just going to hit that one spot. Okay? So just like what we did before, what we need to find is the slope perpendicular. So first we need to find the slope. So I'm looking at 2, -1, and the 0.53, and I need the slope. Now you can do rise over run if you want, or run the slope formula. If I do rise over run, I get 1, 2, 3, 4. 1, 2, 3. So I get rise of 4, run of 3, which would make my tangent line be a -3/4. And then my tangent line goes through the 0.53. So I'm going to use that information to find my equation. Okay, so again, I like doing point slope, so y minus 3 equals a -3/4, x minus 5. I'm going to distribute, whoops, and we're going to need to move that 3 over. So y equals a -3/4 x. Now 3 is 12 over 4. So that's going to make that be 27 over 4. Final answer. Okay? And the very last one that we're going to do. You're given a circle, and you just need to write an equation. So from my picture, I need to find my center and my radius. So I'm going to do from 0 to 6. So I'm going to call this my diameter. 0 to 6, that means my center is right here. So my center is at 0, 3. And my radius, okay, would be 3. So my answer would be x squared, because it'd be plus 0, y minus 3 squared equals 9. Final answer. Okay? So there's some equations again, finding, especially those dealing with tangent.